students, we are going to study the chapter data structure here. It is in section C of your book. So first of all, we are going to see what is called as data structure. Okay. So data structure is a concept of creating logical structures in the memory in such a way that by using small space of the primary memory, numerous data items could be stored. Such structures are array, stack, queue, linked list, tree, graph, etc. Okay. So first of all, we are going to see what is called as a stack. So stack is a memory structure which is similar to a single dimensional array but is used with certain restrictions which are as follows. So in stack, only one end is open for entry and that same end is used for exit of the data. Okay. So no element can be accessed from any middle cell because the entry is one and the exit path also the same entry path. Okay. So we cannot able to access from the middle of the cell. So stack follows last in first out. Whatever we are putting at the last, that we are able to take as first. Okay. So the data structure, the data which are entered in the stack last will come out first and the one that is entered in the stack first will come out last. So this is the figure. For example, there is one bucket. Okay, it is filled with bricks. So the brick that is placed in the last can be taken out first. Okay, and vice versa. So this figure shows the application of a stack. Next, stack contains a pointer called stack pointer. It is indicated as SP, which points the topmost element of the stack. The following operations can be performed with the stack. So what are the operations performed with the stack? Push operation and pop operation. Push means it is a process to enter an element in the stack. Okay, we are filling the stack with the elements, that is called as full. Push operation. To do so, increase the stack pointer by 1. So if we put one element first, so it is in the 0th position, then the stack pointer will move to the first position. Okay, like this it will go on till the stack will fill. Store the defined element at the position denoted by the stack pointer. If the stack pointer equal to n means that is the size of the stack, then no element can be pushed in the stack anymore. This situation is termed as stack overflow. Okay, if the stack is full, the stack pointer, when the stack pointer reaches to the end position, means the stack is full. Okay, after that we cannot able to push any element into the stack. So when the stack is filled till the top, it is called as stack overflows. So the second one is pop. Pop means we are removing the elements one by one from the stack. So we are taken out the elements what we are pushed inside one by one. So at last the stack pointer will reach us to 0. That means the stack is underflow. Okay. This process can be used to retrieve an element from the stack. First of all, take out the element from the stack and then decrease the stack pointer by 1. So during the push operation, the stack pointer is increased one by one, and during the pop operation, the stack pointer will decrease one by one. Okay. If the stack pointer is null means 0, then it indicates that no element is available in the stack and hence popping out of an element is not possible. So this situation is termed as stack underflows. Okay students, now we are going to see the algorithm of the push operation of a stack. So the stack is the stack is a stack with SP as the stack pointer. The stack pointer indicates that either the stack is full or empty. Okay. So if the stack pointer reaches n, this means the stack is overflow. We cannot able to put any element inside the stack. The data items to be pushed into the stack by capacity of the stack is size. Here the capacity of the stack is denoted with the variable size. Okay. So the first step is, first we have to check for the push operation. First we have to check whether the stack is overflow or not. Okay. If the stack is not overflow, we are able to push the elements inside the stack. So the first step is check for overflow. If stack pointer equal to size, size means n, display stack overflows and return. We cannot able to push any other element inside the stack, so we have to display that the stack is overflow and return. The second point, if there is space inside the stack, then we have to increase the stack pointer by 1 every time till the stack pointer reaches to size. Okay. So push the element. Stack of SP equal to item. So we pushed one element inside. We have to repeat the process till the stack pointer reaches to size. Okay. The fourth step is return. Now we are going to see the algorithm of pop operation. Pop operation means we are going to take the elements outside. Okay. So the pop operation, the stack, first we have to see the stack pointer is in the 0th position or not. So if the stack pointer is in the 0th position, means there is no element inside the stack. So we cannot able to pop any elements from the stack. Okay. So the stack is a stack of the capacity size. An element is to be popped out from the stack. Okay. So these are the steps. Step number 1, check for underflow. Underflow means the stack pointer is in the 0th position. So if the stack pointer is in the 0th position, this means the stack is underflow. Display stack underflows return. Then pop out the elements. If the stack is not underflow, then we are able to pop out the elements from the stack. Value equal to stack of SP, display popped out element. So if you popped out one element from the stack pointer will decrease the value by 1. Okay. So decrement of the stack pointer SP equal to SP minus 1 return till the stack pointer reaches to null. Null means 0. So here this is the program to illustrate the stack operations push and pop. So here we are using the array with 20 elements. Okay. Stack pointer, a variable SP, and n is the size of the array. Okay. So first we are taking the elements, 20 elements inside the array. Then s of I equal to 0, then the stack pointer, if the size of the stack is 0, the stack pointer equal to minus 1, n equal to nn. Okay, so this is for the stack operation. So now we are going to write the program for push operation. So the SP equal to n plus 1 system. If it is like that, we are printing it as the stack overflows. Else, we have to increment the value of the stack pointer 1 by 1. Okay. So this is the program for the push operation. Then the pop operation means if SP equal to minus 1, this means the stack is underflow. Okay. So value equal to, if the condition is false, agar stack underflow nahi hai, then we are able to take out the elements from the stack. Value equal to S of SP. System.out.println of popped out element is V. Then we have to decrement the value of the stack pointer. Okay. Then here we are displaying the values. If SP equal to minus 1, display that system.out.println stack empty, else we have to print the stack pointer where it is. Okay, so after that what you have to do is you have to print all the elements, popped out elements and display it. Okay, so this is the program for the stack operation, push and pop operations. Here we are going to see the illustration of the stack pointer. Okay, so the first step is the stack is empty, that is stack pointer is in the null position, so no element is available, hence the stack is empty. So the second point is push an element 5. We are going to push the element 5 inside the stack. So in the stack pointer is in the position 0, that is in the null position, there the number 5 is stored. Okay, so the stack pointer will increment the value by 1 to push the second element. So we are going to push the element 8. Okay, so the stack pointer will reach us to the first position. Now we are going to push another element, that is 12. So the stack pointer will reach us to the second position. Then we are going to push the element 18, so that the stack pointer will reach us to the third position. Okay students, now in the sixth part we are going to push the elements 4, so the stack pointer reaches to 4. So this is the capacity of the stack. Only 5 elements we are able to push inside the stack. Again we are going trying to push the element 6 inside the stack, but there is no space. That means the stack is overflow. We cannot able to push the element 6 inside the stack because the stack is overflow, because the stack pointer reaches its capacity. Okay, so now we are going to pop an element from the stack. Okay, the first element is 4, so we are popping out the element 4 from the stack, so the stack pointer decreases the value by 1, so the stack pointer reaches to the third position. The next step is pop out the elements simultaneously from the stack. We are going to take out the elements one by one from the stack till the stack pointer reaches to 0. So pop out element. So from the 0th position also we are taking out the elements. So the stack will become empty. So that is the stack pointer reaches to null. This means now the element can be popped out from the stack and the stack is underflows. Okay. Now we are going to see the important part, that is the types of arithmetic expressions. Okay. There are 3 types of arithmetic expressions given below. First one is infix, prefix, then next one is infix, and third one is postfix. So prefix means, in the prefix expression, the operator means symbols. Okay, this plus, minus, multiplication, division, these are called as operators. So in the prefix expression, the operator is placed before the operands. For example, plus AB, that is into XY, slash MN. So if the operator is before the operand, it is called as an prefix expressions. Okay, it indicates that the operation is performed on the 2 operands placed adjacent to each other. The next one is infix. In this form of expression, the operator is placed in between the operands. Okay, operands means these variables or the values. For example, A plus B, C minus D, M into N, etc. Here the operator is placed between the in between the operands. So it is called as an infix. The next one is postfix. Postfix means if the operator is placed after the operand, then it is called as postfix. Okay. In postfix expression, the operator is placed after the operands. For example, AB plus XY minus and multiplication, etc. It indicates that the operation of the operand is performed by the operator placed before it. This system is also called as Polish form, and it was developed by a Polish mathematician belongs to Poland. Okay, now we are going to see the rules to convert an infix expressions into prefix or postfix forms. So first step is enclose the parts of the expression under parenthesis according to the Bodmer's system. Bodmer's means bracket of division, multiplication, addition and subtraction. Okay. Then second point is express the contents of the brackets by using operators before or after the operands to convert into prefix or postfix form accordingly. The third point is as the whole expression gets converted, remove all the brackets, that is the converted expression in prefix or postfix form must not contain any parenthesis. Convert the given expression, infix expression, into prefix and postfix forms. Okay, that is a plus b into c upon d. So the conversion of prefix form, first we are going to convert it into the prefix form. So in the prefix form we are going to push the operators before the operand. So a plus b into c upon d. So first inside the bracket we have to go, that is we have to take the multiplication before the operand, multiplication bc. So one bracket we removed. So the next inner bracket is this. So we have to now taken this slash, okay, division symbol before it. So division, multiplication, BCD. So the next bracket also gone. So the next bracket there is no operator. So we have taken this inner bracket. So it will become slash into BCD. Now we are going to take the outer bracket, so the plus will go before A. So it is plus A slash into BCD. So this is the prefix form. Now we are going to convert this expression in the postfix form. Okay. So A plus B into C. So BC, the into will come after this, and we are taken this D here. So the slash will come before D. The next one is we are going to take this bracket, so plus, this plus will come in the first. Okay, so ABC into D slash plus, so it is in the postfix form. So two more problems are there that you have to solve by yourself. Okay, now we are going to see Q. Next, Q is a linear structure which is used to simulate as a single dimensional array but followed with certain restrictions. Basically, it follows first in first out nature. Okay, Q means when we are standing in the line, the people, those who are standing in the first, they will come out first, and those who are standing in the last, they will come out last. So this is the first in first out process. It means that the element which has entered the queue first will come out first. The figure illustrates the operation of a queue. So in this figure shows the queue of peoples in the ticket counter. It is obvious that the person standing first in the queue will get the ticket first. The person standing last gets the ticket last. Okay, so the queue contains two type of pointers, that is front end and rear end. Front end pointer points the data that can be, which can be deleted. So this is the front end and this is the rear end. Okay, so the rear end pointer points the element which is to be inserted last. So these are the following operations can be performed with the queue. First one is insertion and another one is deletion. Insertion means we are going to insert the element into the queue, and deletion means we are going to delete the elements inside the queue. So first one is insertion. It is an operation to store an element in the queue. To perform the task, increase the rear end pointer by 1. Okay, so if you want to insert some element inside the queue, so you have to increase the rear end pointer by 1 and then insert the element. So if the rear equal to n, that is size of the queue, then no more element can be inserted into the queue. So this situation is known as queue overflow. Next one is deletion. It is the process to delete an element from the queue. To delete an element, first of all perform the deletion and then increase the front end. Okay, so during the deletion operation, we have to increment the front end pointer by 1. Okay, if rear end and the front end pointer points null, then there is no element available in the queue. So this situation is known as queue underflow. Okay students, now we are going to see the illustration of queue, deletion, insertion and deletion in a queue. First the front end is null and the rear end also null, so that no element is available in the queue, hence the queue is underflow. Okay. Second, we are going to insert an element 5 into the queue. So we are going to insert the first element inside the queue. So the front end become 0 and the rear end also 0. Now we are going to insert the next element 8. So the front end is 0 and the rear end will show 1. Now we are going to insert the next element 12. So the front end is 0 and the rear end is 2. Now, so this is called insertion operation. Now we are going to see the deletion operation from the queue. So now we are going to delete one element from the queue, that is 5. Okay, so the element 5 is deleted from the queue so that the front end become 1 and the rear end is 3. Now we are going to insert the 7th element. So the front end is 1 because we deleted one element from the queue and we inserted it here. So the rear end will become 4. Now the queue is full. Okay. So insert an element 31 into the queue because the rear end reaches to the size of the queue. So we cannot able to insert any element inside the queue. So we cannot able to insert the element 31 in the present queue. So this means the queue is overflow. Okay. Now we are going to delete an element from the queue. That is, we are going to delete the element 8. So the front end become 2 and the rear end will become 4. Now again we are going to delete the element. So the front end become 3 and rear end element will become 4. And now again we are going to delete the element 25. So the front become 4 and the rear become 4. Now again we are deleted the last element. So the front also become null and the rear also become null. So if the front end and the rear end reaches to null, this means the queue is underflow. Okay, so this is the operation of a queue. Okay students. So this is an algorithm to insert an element in a circular queue. Okay, so you have to learn the algorithms, that is delete an element from the circular queue, then that is the program to illustrate the operations, that is how to push the elements inside the queue, and how to delete the element from the queue. Okay students, so these are the programs you have to practice. The next one is DQ. DQ is referred as double-ended queue, in which insertion as well as deletion can be performed at both ends. Okay, that is the double end, that is we are able to insert element from the front end as well as we are able to insert element from the rear end. It is different from symbol queue or circular queue in the aspect that it has both the ends open for insertion and deletion purpose. So it also has two types of pointers, that is front end and rear end pointers, which enables insertion as well as deletion at both ends respectively. So in the symbol queue, we are able to insert an element from the back side. Okay, so we are removing the elements from the front. But in this D queue, double-ended queue, that is, we are able, two pointers are there, that is the front end and the rear end. We are able to insert the elements through the front end as well as through the rear end, and we are able to delete the element through the front end as well as in the rear end. Okay, so to insert an element at the front end pointer decreases by 1 but increases by 1 to delete. So to insert an element in the rear end pointer increases by 1 but decreases by 1 to delete. So this is the algorithm to insert an element in the DQ. Okay, then we are going to see the delete an element from the DQ. So here we are to use 3 enter. Okay, now this is an important portion of this chapter, that is tree. Tree is a non-linear data structure which is created with double linked list. Okay, so the trees. So a tree starts with a list called root. Okay, and goes on expanding through its left and right links. Each link of the double linked list represents the list and so on. So now we are going to see the binary tree. Okay, so the binary tree is a tree structure in which each node must have at most 2 branches. That is, there may be 2 nodes, single node, and no node from any node of the structure. So this, see, this is the structure of a binary tree. So this is called as a root. Okay, B and I are called as the branches, that is the child of this A, and B is having 2 children, that is C and D, and D having 1 child, 2 children, that is G and H. C is having 1, that is E, and E is having 1 and F. Okay, so this is the root and these are called as children and grandchildren. Okay, so if any node is not having any leaves, that is called as the siblings. Okay, now we are going to see one by one. Features of a binary tree. A binary tree contains, binary means 2. A binary tree contains only one root node. So root node is 1. Each node contains 2 children at most. A node can have only one parent node. Okay, so a predecessor node cannot be the child node of a successor. So see here, this is called as the predecessor and this is called as the successor. Successor is always a child and predecessor is always a parent. Okay, so different terms related to binary tree. First one is root. Root means the first node. It is the starting node on the binary tree structure. This node is not a branch of any node, but other nodes originate from this node. So in this figure, A is the root of the root of this binary tree. Okay, the first node is called as the root node. So the next one is subtree. In a binary tree, each node is referred as a root for its children or grandchildren. Such node along with children and grandchildren is collectively known as subtree. Okay. Next one is height of the tree. Height of the tree is defined as the number of nodes in the longest chain. So in this figure, the height of the tree is 5. See how to calculate the height of the tree. That is, this is 1. First node is 1. This is the second node 2. And this is the third stage 3. And this is the fourth stage, that is 4. And this is the fifth. So this is called as the height of the tree. Height of the tree will start from 1. Level of the tree is height minus 1. That is 0, 1, 2, 3, 4. Or you have to first find out the height, that is 1, 2, 3, 4, 5. 5 minus 1, that is the level of the tree. Okay. So the height of the tree is defined as the number of nodes in the longest chain. In the figure, height of the tree is 5. The next one is level of the tree. Number of nodes in the longest chain except root node is termed as level of the tree. Level of the tree is height minus 1, that is 5 minus 1 equal to 4. So now we are going to see the predecessor. Predecessor or the parent node is a node which has branches in it. Now a predecessor is referred as respect to another node. For example, node B is the predecessor of the node C. Here the node B is the predecessor of this node C, and node C is the successor of the node B. Okay. So successor is also called as the child node. Successor is defined as the node which is a branch of another node. Successor is also referred with respect to another node. For example, node C is the successor of node B and node J is the successor of node I. Now, leaves or siblings. So if there is no child after this, okay, if the node is blank without child, it is called as leaves or siblings. Okay. So leaves are such nodes which have no child branch out of this. These nodes terminate a tree which helps in defining in height and level of the tree. Now we are going to see the binary tree traversal. There are three types of traversals. Traversal means processing a tree. There are three types of traversal in a binary tree. That is in-order traversal, pre-order traversal and post-order traversal. So in-order traversal means from left to left. First we have to go to the left portion, then reaches the root, then right. In this system, traversal is performed by using the following steps. First one is traverse the left node. Second one visit the root node, and third one traverse the right node. Okay. Then pre-order traversal means root, left, right. In this system, first visit the root, then traverse the left node and traverse the right node. Third one is post-order traversal. That is, first you have to traverse to the left node, then right node, then root. So for writing the traversal of the trees, you have to learn these rules. Okay, that is, in-order traversal means left, root, right. Pre-order traversal means root, left, right. Then post-order traversal means left, right, root. So here one figure is there. Write the processing of the node in traversal systems. First, pre-order traversal. Pre-order traversal means root, left, right. First we have to go to the root, that is A. Then left side we have to go, then B, C, D. Then next left side nothing is there, so you have to go to the right side, E, F. Okay, so the left portion is over, then we are going here in the right. Right also we have to follow the same rule, that is left, right, root. So first is G, then H, I. This is pre-order traversal. So in-order traversal, next we are going to write the in-order traversal. In-order traversal means left, root, right. Okay, first we have to go to the left. This is the left, so C, left, root, right. Okay, so C, B, D, then F, E, then root is A, then right H, then left I, then G. G is the root. Okay, so the post-order traversal. Post-order traversal means left, right, and root. Okay, so left, right, and root. So C, F, E, D, B, I, H, G, A. So this is the traversal, binary tree traversal. Okay, so in-order traversal, the rules are there, and in-order traversal, the algorithm is also here, and this is the rules for pre-order traversal, and this is the algorithm for pre-order traversal. Okay, so this is the rules for post-order traversal, and this is the algorithm for post order traversals. Okay, so students, the data structure chapter is over. You have to practice more binary trees and the infix, postfix notation, stack and queue. Okay students.